Welcome to Calculus Crush. Today we're going to be looking at the definition of the derivative. We're going to derive the equation of the derivative. In order to understand the derivative, we need to be able to figure out the slope of a line. So let's draw a graph and a function. I'll draw my y-axis here and my x-axis here. And now I'm just going to draw any old function. I'll just draw like a big curve, something like that. And if we put 2 points on this curve, and we draw a straight line through them, connecting the 2 points, we can figure out the slope of this line. Remember, the slope of a line is just the change in y over the change in x, or rise over run. So let's write that out. The slope of a line is equal to the change in y over the change in x, which we also say rise over run. Now that's the slope between 2 points. When we calculate the derivative, what we're actually trying to figure out is the slope at just 1 point. So the way we're going to do that is we're going to try and make the distance between these 2 points really small. Now I'll show you how we do that. I'm going to get rid of this delta x and delta y. And what we're going to do is we're going to say that this function, or this curve here, is f of x. So the value of the function at this first point, I'm going to say the x value is just x. Therefore, the y value is going to be f of x. Now at this second point, I'm going to say that the x value is going to be x plus h. So you can see here, this first value is x. The second value is a little bit further away, and I've called that distance h. Now the corresponding y value for this second point is just going to be f of x plus h. So the difference, or the distance here, is just f of x plus h minus f of x. So if we were to calculate the rise over run, the change in y over the change in x, that would be equal to f of x plus h minus f of x, all divided by, so this is the rise, f of x plus h minus f of x, and the run is just this distance h. So this would be the slope of a line that connects 2 points separated by a distance h. Now, to calculate the derivative, all we want to do is take this h and we want to make it go to 0. If h is 0, then the second point and the first point are the same point. So in order to do that, we need to use the concept of limits. So now, instead of a change in y over a change in x, we use a different notation. We use dy by dx. And we take the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. And this is the definition of the derivative. And the derivative is the slope of the tangent line at a given point. So for this point, let's see if I can draw it. It should just touch the curve at one point. So you can see the slope of this line is different from the slope of a line that connects 2 points. But as we move this point here closer and closer, here and then here and then here, and then eventually we get infinitely close. Technically we still have 2 points, but they're infinitely close together. We get the slope of the tangent line right here. So if you were to actually solve this right now, if you were to replace all of your h's with 0, you would just end up of f of x minus f of x divided by 0, which is 0 over 0. Now what is 0 over 0? 0 over 0 is undefined. It could be anything. It could be 0, it could be 1, it could be a million, it could be x squared plus 5. You don't have any information if you have 0 over 0. So normally when you do problems, when you actually calculate the derivative, what you're going to end up doing when you substitute in f of x plus h and f of x, you're going to be able to factor out an h. You're going to have h times some stuff divided by h, limit as h goes to 0. And so you're going to be able to cancel out the h over h, or the 0 over 0, and you're just going to end up with limit as h goes to 0 of some stuff. It'll have some h's, some x's, whatever, but it'll end up giving you an answer which is a real answer, not undefined, not 0 over 0. So this is the definition of the derivative. A little bit more information on that. Why do we care about the derivative? Well, we care about it because it tells us what the instantaneous rate of change is at a specific point. Whereas when we calculate the slope between 2 points, what we're calculating is the average rate of change. So this expression, delta y over delta x, you can think of as the average rate of change. Whereas dy by dx, this is the instantaneous rate of change. Another way you can think of it is these deltas here are like big D's, big changes. And these little d's, well, they're little d's. So it's a very small rate. We're looking at a very small change, whereas this is over a big area, or over a big distance, or over a big time. So an example of the difference between an average rate of change and an instantaneous rate of change would be if I'm driving my car from Saskatoon to Calgary, and let's say it's 600 kilometers, and it takes me 6 hours to drive there, then I know that my average rate of change, my average speed, velocity, which is a rate of change of position, my average rate of change is 100 kilometers per hour. But it doesn't tell me anything about my instantaneous rate of change, because maybe at one point in time I was going 140 kilometers an hour. At a specific point in time, my instantaneous rate of change, or my instantaneous velocity, was 140 kilometers an hour. But then later it went down to 60 kilometers an hour. So that's kind of the difference between average rates of change and instantaneous rates of change. With the derivative, we're able to calculate the instantaneous rate of change at all points along a curve. And this is very important in science, math. Thanks for watching. If you have any questions, please leave them in the comment section. Until next time.